Imagine AI systems that don't just answer your questions, but can actually plan things out, use tools, and even, remember important info across really complex tasks. We're talking about systems acting autonomously out in the wild, dynamic environments. This isn't just about bigger models anymore. It feels like a real shift, doesn't it, towards AI becoming true agents.
It really is a fundamental shift.
So today, we're taking a deep dive into this comprehensive survey paper. It's from researchers at IBM, Yale, and the Hebrew University of Jerusalem. And it maps out this,
Yeah, because this new agency, this ability to act, it lets these AI systems tackle problems that were just well out of reach before. It's opening doors for innovation across so many different areas.
but as they start acting independently, making decisions,
Mhm.
well, like you said, reliable evaluation isn't just nice to have, it's absolutely critical.
It is, to ensure they work, to make sure they're safe, and honestly, just to guide where the research goes next in this fast-moving field.
Okay, so before we get too far ahead, maybe you can help break down for everyone listening. What's the core difference between one of these LLM agents and the standard LLMs most folks are maybe playing around with?
Sure. So standard LMMs, as most people know them, are kind of static, right? They're generally restricted to a single back and forth, text in, text out. LLM agents, though, they take that language power and build on it significantly. They integrate the LLM into a flow that involves multiple steps.
Mm.
And crucially, they maintain a shared state like a memory for context and consistency across those steps.
Oh, okay. So they remember what happened earlier in the task.
Exactly. And just as important, they use external tools. They can perform calculations, look up current information, or even interact with software or websites. That ability to act and adapt based on new information is really key.
And I guess those very features, the multi-step actions, the tool use, the dynamic nature, that's what makes evaluating them so tricky.
Precisely. Their reliance on specific LLM abilities, the fact they operate sequentially in environments that can change, their ability to tackle really diverse, complex tasks,
Hmm.
all that introduces new and pretty significant challenges for evaluation. It's not just about getting the final answer right anymore.
So this paper, it's really aimed at a wide audience within the AI world then.
Oh, absolutely. It's for the developers actually building these agents, assessing their capabilities. It's for practitioners trying to deploy them in real applications. It's definitely for the benchmark developers struggling with these evaluation challenges, and really any AI researcher interested in agent capabilities, their risks, their limitations. It covers the whole spectrum.
Right. So to really get a grip on how these agents operate, we need to look at their foundational capabilities. Let's start with planning and a multi-step reasoning. This seems like the absolute bedrock, doesn't it? An agent's ability to tackle complex stuff, breaking down problems, figuring out the steps.
It absolutely is. It's how they decompose big problems into smaller, manageable subtasks and then create a strategic path to execute them. And yeah, we're often talking about tasks needing a sequence of logical steps, maybe say 3 to 10 intermediate operations.
Okay, and the paper talks about how this is tested.
It does. It mentions benchmarks for mathematical reasoning, like GSMAK, for multi-hop question answering needing to combine info, things like hot pot QA or strategy QA. And it goes further, looking at logical reasoning with benchmarks like Folio, and even common sense reasoning like in MUSR.
Now, here's something I found really interesting in the paper. It says even the really advanced LLMs struggle with what they call long horizon tasks. The MINT benchmark showed this. And apparently, current models are good at short-term tactical planning, but still lag behind classical symbolic planners for everyday stuff, according to AutoPlan Bench. What does that gap tell us? Is AI not great at strategy yet?
It's a fascinating point. It tells us that while LLMs are amazing at language and short burst reasoning, that really deep long-term strategic planning, anticipating many steps ahead,
Hmm.
adapting to major changes, that's still a huge challenge. They're good tacticians, perhaps, but maybe not yet great strategists in that very human sense.
So what needs to improve?
Well, the benchmarks point to key abilities. Things like task decomposition, obviously, but also state tracking, keeping tabs on how things change.
Hmm.
Belief maintenance is part of that. There's self-correction, recovering from mistakes, causal understanding, knowing why an action leads to a result, and even meta-planning, sort of thinking about the plan itself. These are all areas needing work to bridge that gap you mentioned.
Okay, moving on. The next core capability, function calling and tool use. This seems absolutely fundamental if you want an agent that can actually do things in the world, not just talk about them, get real-time info, interact.
Exactly. It's not just about information retrieval. It's about action.
Yeah.
And it involves this whole sequence, this flow. First, the agent has to recognize the intent. Like, okay, The user needs something. I can't just answer. I need a tool.
Right.
Then function selection. Which tool is the right one for the job?
Mm-hmm.
After that, parameter value pair mapping, basically, pulling the right details, the arguments from the conversation to feed to the tool.
Like dates for a flight booking or something.
Precisely. Then the function execution, the tool does its thing, interacts with the outside world, maybe an API call. And finally, response generation. The LLM gets the result back from the tool and weaves it into a natural response. It's quite a dance.
And the evaluation for this has gotten more complex too, hasn't it? It started simple.
Yeah, early efforts were often just single one-step interactions. But that's where it gets really interesting, as the paper points out. Recent benchmarks like BFCL v2 and v3, they've introduced multi-turn and multi-step evaluation. This mimics real-world complexity much better, emphasizing that state management we talked about, remembering things across turns.
So the agent needs to remember what the tool did last time.
Exactly. And benchmarks like Tool Sandbox go even further, incorporating stateful tool use and dynamic evaluation. Complex Func Bench looks at tricky situations like inferring parameters that weren't explicitly stated or following user constraints. And then you have things like Nestful, focusing on these really complex nested sequences of API calls where the output of one tool becomes the input for the next. That's very representative of real-world workflows.
Okay, another really interesting capability is self-reflection. The idea that agents can learn from mistakes, improve their reasoning through feedback.
Yeah, can they dynamically update their beliefs and adjust their actions based on feedback or errors? It's a huge question.
Right. But evaluating it seems hard. The paper said early evaluations were often indirect, maybe just checking if the final answer got corrected.
Right, often coarse, as the paper puts it, and lacking standardization. But now there are dedicated efforts. LLF Bench is specifically designed as a standardized benchmark for this kind of interactive self-reflection. And Reflection Bench takes a cognitive science angle, breaking reflection down into components, perceiving new info, using memory, updating beliefs when surprised, adjusting decisions, even counterfactual reasoning, thinking what if, and meta-reflection, thinking about its own thinking process.
That raises a deep question, doesn't it? How much can an AI truly understand its own mistakes versus just, statistically correcting?
That is the deep question in this area, absolutely.
All right, final foundational pillar. Memory. You mentioned it earlier with state, but this is broader, right? Handling long conversations, retrieving info, overcoming the fact that LLMs are trained on static data.
Exactly. Agents need short-term memory for immediate context in a conversation, but also long-term memory for deeper understanding over time, recalling past interactions or learned information.
And there are innovations happening here.
Oh, yes. The paper mentions things like Read Agent, which structures reading tasks by condensing content into memories. MemGPT uses a tiered memory system, kind of like how computers use RAM and disk storage. AMEM proposes an advanced memory architecture, evaluated with the Locomo benchmark. These are all attempts to give agents more robust, persistent recall.
Now, one finding that really jumped out at me was from the LTM benchmark long-term memory benchmark. It looked at conversational agents in these long multitask chats with lots of context switching. And the find was basically that short context LLMs with good long-term memory systems could match or even beat models with much bigger context windows on these interleaved tasks. Why is that such a big deal?
It's potentially a game changer. It suggests that just making the context window bigger and bigger isn't the only way, or maybe even the best way, to handle long, complex interactions. Smarter memory management, even with a smaller immediate context, could be more efficient and just as effective, especially when tasks are jumbled up, like in real life.
So for developers, this could mean building powerful agents without needing these enormous expensive models.
Exactly. It points toward a potentially more efficient, maybe cheaper agent architectures that can still handle the complexity. It really opens up new design possibilities.
Okay, so we've covered those core building blocks. Now let's look at how agents are being evaluated in specific real-world applications. The scope here is massive. Let's start with web agents.
Right, so these are AI systems designed to browse websites, interact with them, do tasks like booking flights, online shopping, that kind of thing.
And the evaluation has evolved quite a bit here, too.
Definitely. It started with basic simulations like MiniWob, then moved to static website datasets like WebShop. But now, the push is towards highly dynamic online benchmarks. Things like Web Arena and Visual Web Arena really try to mimic live websites. And importantly, Visual Web Arena requires agents to understand visual elements on the page, not just text.
And Work Arena plus and.
That simulates complex office tasks that might involve multiple web interactions over time.
So with all this progress in making benchmarks more realistic, what's the catch? Are there still gaps, particularly around safety or real-world deployment?
That's a key point the paper makes. Despite the advancements, critical aspects like policy compliance, making sure the agent follows the rules, risk mitigation, adhering to safety protocols, these remain underexplored. So there's a gap between demonstrating capability in a benchmark and ensuring safe, reliable operation when you actually deploy it. That needs more focus.
Makes sense. Okay, next up, software engineering agents. These are helping with everything from writing code to fixing complex bugs.
Yeah, a huge area. And SWE Bench really stands out here. It's built from actual real-world GitHub issues. So the evaluation includes the full issue description, the entire code repository, and validation tests. It's incredibly realistic end-to-end.
Wow, that sounds tough.
It is. And the challenges are growing. SW Bench Multimodal adds visual aspects, testing agents on problems involving GUIs or visual elements in software, highlighting difficulties in visual problem solving. And SW Lancer focuses on freelance coding tasks, trying to link agent performance directly to monetary value. It really underscores how hard long-term reasoning and decision-making are in these complex real-world coding scenarios. They're not replacing human devs wholesale just yet.
No, definitely not. Okay, switching gears dramatically, scientific agents. Using AI to speed up research.
A really exciting domain. And evaluation here has moved way beyond just testing knowledge recall, like in Science QA. Now, benchmarks are assessing things like scientific ideation. Can the agent generate novel research ideas? Experiment design. Can it formulate testable hypotheses? Even code generation for experiment execution, writing accurate scientific code. And incredibly, peer review generation, evaluating research papers with feedback comparable to human reviewers.
That's amazing. And it's not just separate tasks anymore, right? There are integrated environments.
Exactly. Frameworks like Discovery World offer a virtual text-based lab, essentially.
Yeah.
It simulates the entire scientific discovery cycle across loads of different tasks, forming hypotheses, running experiments, interpreting results. True integrated discovery simulation.
Wow. Okay, finally in this application section, conversational agents, like customer service bots, but smarter.
Precisely. Customer-facing agents handling requests, but needing to follow company policies, engage in complex, multi-turn dialogues to actually complete tasks.
And how do you benchmark that effectively?
Well, one way is predicting the next step in a known, good conversation, a ground truth trajectory. Another is simulating both the environment and the user interacting with the agent.
And there are specific data sets for this.
Yeah, examples like ABCD, which has thousands of real customer-agent conversations covering many different user intents. Bench simulates dynamic conversations using an LLM as the user in areas like airline or retail support. And Intelligent offers an open-source framework to automatically benchmark agents against company documents and policies, which is really practical for businesses.
So we've seen agents specialized for the web, for coding, for science, for conversations. But the trend is towards more general purpose agents, isn't it? That's the big picture.
Absolutely. As the underlying LLMs get more powerful, agents are moving beyond narrow applications towards systems that can potentially handle a much wider range of tasks.
And the benchmarks reflect this shift.
They do. Benchmarks for these general agents focus on combining those core capabilities. Multi-step reasoning, interactive problem solving, using tools effectively. GIIA, for instance, uses hundreds of human-written, real-world questions that test reasoning, understanding images, browsing the web, and general tool use, all mixed together. Agent Bench uses interactive environments like a simulated operating system, a database, even games to test broad competence.
And then there's this idea of agents in the workplace. That sounds like science fiction almost.
Well, it's becoming benchmark reality. New benchmarks are evaluating agents in simulated digital work environments, doing tasks like human employees. The agent company, for example, creates this environment like a small software company. Agents have to browse internal sites, write code, run programs, maybe even interact with simulated coworkers.
Wow.
And CR Marina focuses on customer relationship management, simulating complex enterprise tasks using user interfaces, APIs, and needing to stick to company policies.
So what does this really suggest for the future of work? Are we looking at digital coworkers?
It strongly suggests a future where AI agents are much more integrated into daily operations, handling complex, multifaceted tasks. It's moving beyond simple automation. It really does raise profound questions about human-AI collaboration, workflow management, how jobs might change. It's a huge shift these benchmarks are preparing us to evaluate.
And to try and bring all these different general benchmarks together, there's something called HAL.
Right, the Holistic Agent Leaderboard. It acts as a standardized platform, aggregating scores from multiple benchmarks covering coding, interactive tasks, safety assessments, trying to provide a more unified view of general agent capabilities.
Okay, so we have all these benchmarks comparing finished systems. But the paper also talks about evaluation frameworks. How are they different?
That's a key distinction. Benchmarks are usually for comparing developed systems. Evaluation frameworks are more like integral parts of the development process itself. They allow developers to continuously monitor their agents during development, do deep dives into errors, and even design and evaluate their own specific scenarios, not just predefined benchmark tasks.
So they're more like a toolkit for the developers building and testing the agents day to day.
Exactly. A toolkit for continuous improvement. They provide ongoing monitoring of how the agent performs its trajectory, looking at metrics like task completion, speed, latency, things like that.
And they operate at different levels of detail.
Right. You could have final response evaluation. Did the agent get the final answer right?
Yeah.
Off using other LLMs as judges, which is interesting in itself. Then there's stepwise evaluation, which is much more granular. It looks at each individual action the agent takes or each call it makes to the LLM. This helps pinpoint exactly where things went wrong, root cause analysis.
And the paper mentions an action advancement metric.
Yeah, from Galileo Agentic Evaluation. That metric specifically measures if each step the agent takes actually moves it closer to the final goal. It's a richer form of feedback than just pass-fail for the step.
And trajectory-based assessment, looking at the whole path.
Right, analyzing the entire sequence of steps compared to maybe an ideal or expected path. But the paper points at a major challenge here: the non-deterministic nature of these agents. Often, there isn't just one right way to solve a problem. There can be multiple valid solutions. That makes defining a single optimal path really, really difficult, which complicates this kind of evaluation.
Okay, and these frameworks also help with managing data, getting human feedback.
Yes, they support curating input data, integrating human-in-the-loop feedback, maybe from users interacting with the agent in production. They can help generate synthetic data for testing and support A/B comparisons to see which version of an agent performs better side by side. It's a comprehensive suite.
And finally, gym-like environments, like for reinforcement learning.
Exactly, inspired by OpenAI Gem. They provide these controlled, interactive, simulated environments where agents can be trained and evaluated on realistic tasks, allowing for faster iteration and testing.
Okay, this field is clearly moving incredibly fast. Based on the paper, what are the biggest trends shaping how we evaluate these agents right now? And maybe more importantly, what are the critical gaps or future directions we need to focus on?
Well, one clear trend is the push towards more realistic and challenging evaluation. We're definitely moving away from simplified static tests. The benchmarks are increasingly trying to more accurately reflect real-world complexities, whether that's interacting with live websites, tackling real GitHub issues, or simulating complex scientific processes.
And part of that realism is making them harder, right? The paper mentions benchmarks like SWE Bench and GIIA, where top scores are sometimes incredibly low, like 2%. What does a score that low actually tell us? Is it just that the agents are bad?
No, not necessarily that they're bad. A score like 2% on a benchmark like GAIA tells you the benchmark is incredibly difficult and is really pushing the frontier. It means there's a massive gap between current agent capabilities and the complexity of the real-world tasks being posed. Researchers want these hard benchmarks because they highlight the biggest challenges and force innovation in areas like long-horizon reasoning, robustness, tool use. It shows how much room there is still to grow. It's actually a good sign for driving progress.
Right, it defines the edge of what's possible. Okay, what other trends?
Another big one is the move towards live benchmarks. Because LLMs and agents evolve so quickly, a static benchmark created last year might already be too easy or irrelevant. So we're seeing this shift to adaptive and continuously updated evaluation methods. Think about the evolution of BFCL we mentioned, or how SWE Bench keeps getting refined. This dynamic approach is vital to keep the evaluations meaningful.
Okay, so things are getting more realistic, harder, and more dynamic. Now, what about the gaps? Where does future research need to focus most urgently?
One major area is advancing granular evaluation. As we discussed, many benchmarks still rely on pretty coarse-grained end-to-end success metrics. Did it work or not? But that doesn't tell you why it failed. So future work really needs to focus on developing standardized, fine-grained evaluation metrics that capture the trajectory, the step-by-step process, give much richer feedback for improvement.
Makes sense. You need to know where the breakdown happened. What else?
Cost and efficiency metrics. This is huge. Right now, evaluation often focuses heavily on accuracy, but tends to overlook cost and efficiency. This can lead to agents that are amazing, but incredibly resource-intensive to run.
So practically useless if they cost too much.
Exactly. Future frameworks need to integrate cost efficiency as a core metric, tracking things like token usage, how many API calls are made, inference time, overall resource consumption. It's about balancing performance with practical viability.
That seems crucial for actual deployment. What about scaling the evaluation itself? It sounds like a lot of manual effort goes into this now.
It does, and that's not scalable. Relying on human annotation is a bottleneck. So future directions include using synthetic data generation techniques more heavily. And a really interesting idea is automating evaluation by employing LLM-based agents as evaluators. They call this agent as a judge. The goal is continuous, fine-grained, and cost-effective assessment without needing humans for every single check.
Using agents to evaluate other agents. Interesting. Okay, and the last big gap the paper highlighted.
Safety and compliance. This is arguably one of the most significant shortcomings right now. Current benchmarks have a very limited focus on safety, trustworthiness, or adherence to rules and policies.
Which seems incredibly important if these agents are acting autonomously.
Critically important. The big question the paper raises is, how do we ensure these systems are not just effective, but also robust? Robust against adversarial attacks, mitigating bias, adhering to organizational rules, societal norms, legal constraints, especially when you think about multiple agents interacting, what emergent risks might pop up. This is a massive area for future research to ensure these powerful tools are deployed responsibly.
Absolutely. Well, we have certainly taken a deep dive today into this really complex world of LLM-based agent evaluation. We've looked at their core capabilities, how they're tested in all sorts of applications, the frameworks helping build them, and these critical trends shaping their future.
Hopefully, this is giving you, our listener, a solid grasp on how researchers are tackling the challenge of making sure these increasingly powerful autonomous AI systems are not just smart, but also reliable, efficient, and crucially safe.
So as these LLM agents become more woven into our digital lives, maybe even our physical world, the evaluation challenge really shifts, doesn't it? It goes beyond just measuring performance to ensuring ethical, responsible operation. So here's a final thought for you to ponder. What aspects of agent intelligence and behavior do you think will be most important to evaluate for us to truly trust these systems in the years ahead?